The third and final method that we're going to be learning to solve a system of equations is called elimination. We've been through graphing, we've been through substitution, and now we can get to elimination. Now, just like with substitution, we substituted something in to solve the equation. With elimination, we're going to eliminate a variable to make a smaller equation and then have a way to find our solution, the x and y coordinate. But what we're going to need to find is equal but opposite coefficients, or what I like to call opposite terms. So opposite terms are just the positive and negative of a certain term. Same coefficient and variable, but opposite signs. So like if it was 3, the opposite term would be -3. If it was positive y, the opposite would be -1y. And if it was -7x, the opposite term would just be a positive 7x. That makes a lot of sense. Now, there are 3 steps to solving something by elimination. The first step, we won't see that often, but that first step is to multiply one or both of the equations if there aren't already opposite terms, okay? So that's going to be a step that we may have to take. We can call it manipulating the variables, manipulating the equations, but we just multiply one of the entire equations by a scalar. Step 2 is really where you'll see what happens. We're going to add together the 2 equations, like an old-fashioned addition problem, and then be able to solve for one of the variables. Okay, it's going to happen real fast, and then we're already halfway done because we have one part of our solution. But then we're just going to substitute that value, back into one of the original equations to find the other coordinate. So let's look at the example here. We have a question that says, what is the solution to the system of equations? So we're looking for x and y. And you should notice that we already have opposite terms right here on the x. You have 10x and -10x. That's good. I just need one of the variables to be opposites. It could either be x or y. As long as they're opposites, we're good to go. So if you look at my work here, what we've done is we've added together the equations like a big old plus sign. That eliminates the 10x and the -10x. And then I add straight down. I have -5y plus -2y, that's -7y. 0 plus -14, that's -14. So literally just adding in the columns straight down. Then I just quickly finished solving for y. I divided by -7 on both sides, and I got that y is equal to 2. Woohoo! I already have half of my solution. Already. I added the 2 equations together and one of the variables canceled, and then I just quickly solve for y. So I'm taking one of the original equations. So I took the top equation, out of habit, I always pick the top one, and I rewrote it down, but this time, instead of putting a y right here, I can substitute in that value 2 that we just got for y. And then if you see the next step, it said 5 times 2 is -10. So then I have 10x minus 10 equals 0. I'm going to add 10 to both sides. I didn't really leave enough room to show what I was doing here, but I added 10 to both sides so that those eliminate because they're opposites. I divided by 10 on both sides to get that x is equal to 1. And voila, we have created our coordinate answer 1, 2. That's the solution to this system. That's the point where these 2 lines would meet. It would be at 1, 2. That's the solution there. Okay, now elimination truly only works if you have those lined up variables, one a positive, one negative, with the same number in front of it. If it's not like that, you're going to have to do step 1, or maybe just choose to solve both of them for y and graph. Okay, let's see another example here. This question is asking me for the solution to the system of equations. Okay, so solution, that means I'm looking for the x, y of this. Great. I notice that these are set up in standard form. And I notice, again, that I have the positive and negative of the same variable. That's my hint that I might want to solve this one with the elimination. I totally could just solve these for y and graph them, but because I noticed that this lined up thing, the matching equal but opposite coefficients already exists for this problem, I'm just going to go ahead and use elimination. Okay, so I'm going to add together the whole equations. The things that are opposite, they eliminate, they go away. Okay, then I add negative 1y plus 3y. Well, that's 2y. And negative 2 plus 10, that's 8. I know how to quickly solve for y. I'm going to divide by 2, so y is equal to 4. That's half of my solution. To find the other half, I'm going to take one of the original equations. I like choosing the top one, just out of habit. And anywhere I saw a y a second ago, I am instead going to place a 4. Because y is 4. Okay, this is a two-step equation, so pretty simple. I'm just going to go plus 4 on both sides, plus 4. This is the box method, or inverse operations. Negative 2x equal to 2, so negative 2 plus 4. I'm going to divide by negative 2, divide by negative 2. We get x is equal to negative 1. So I know that my final solution is the x value and the y value, negative 1, 4, that I got from the steps to use elimination. So again, the steps are, if you notice that this is set up this way, you're going to eliminate that particular variable by adding the two equations together straight down and quickly solving for one of your answer choice, for one part of your answer. But then you take that value and you plug it back in and then solve for the other one. Really just some wild algebra work here. Let's do one more. It says, what is the solution again? So, okay, solution, I'm looking for both x and y to the system of equations. Do you notice that this has opposite terms? Doesn't matter if it's x or y, they just need to be opposites. So I'm good to go. I'm going to write this one down again. So 2x minus 2y equal to 10, and negative 4x plus 2y equal to negative 22. And I'm going to add these two things together. Now, the x's do not cancel in this example. The y's are going to cancel because they're the ones that are opposites. I would get negative 2x when I add 2x and negative 4x. And I would get negative 12 when I add together the constants. Divide by negative 2, divide by negative 2. Okay, great. I know that x is equal to 6. That's half of my answer. But I'm going to take that answer and I'm going to plug it into one of the original equations again. And it doesn't matter if you use the top or the bottom. I always just use the top. That's what my habit is. And I'm going to write down the same equation again, but if there is an x, instead I'm going to put a 6. And then I keep solving this equation the way I have before. 2 times 6, that's 12. 12 minus 2y equal to 10. We're going to subtract 12 on both sides, using inverse operations to get that 2y by itself. That would end up being negative 2. Divide by the coefficient of y, and y is equal to 1. So now that I've gotten both parts of this equation, both x and y, I can put them together as my solution, 6, 1. That's going to be the location of where these two lines cross if I had graphed this system. That's the solution to this system of equations. So now you have 3 methods that you can use to solve systems of equations. Graphing always works, substitution works, and elimination will work if it's set up properly for elimination.